Right, we have reached the final lecture of the course. Um, Congrats for sticking through it. I hope you learned something. Hope you enjoyed it a bit. Um, so the last thing we're going to talk about is so to set the stage, right? You'll recall we had Nagel's account of reduction. We had Jerry Fodor arguing, well, on that account of reduction, probably not going to have much actual reduction going on. It doesn't seem like special sciences are going to be able to be reduced to the primary sciences in the way that Nagel described for various reasons. Watch that lecture, right, for the details. So the Churchland reading, Paul Churchland, who is a member of our department, as well as his wife, Patricia Churchland, they've done a lot of great work in philosophy of mind and then also in philosophy of science. Um, he has a different account of reduction that he thinks will allow for the reduction of, or at least some psychological states, the brain states, and maybe more applicable more generally, but um, it's a particular puzzle that people have trouble with in philosophy of mind, and it's a good test case. So, so in the last lecture, Fodor argued that it's highly unlikely, if not impossible, that psychology is going to be reduced to neuroscience because of the many ways that psychological states could be implemented neurally. And so Churchland wants to narrow in on a particular type of psychological state. It's one that people think is particularly difficult to reduce to physical states, um, and what they call qualia. So, what is qualia? Basically, things like conscious experiences, color experiences, smells. People have described it as the what it's like experience. I don't find that particularly helpful, but maybe one way to look at it, you may all recall sort of this dress issue, right? Where some people saw it as a blue dress, other people saw it as a white dress. Um, and what's interesting about that is the physical state of the dress is exactly the same, right? You're both looking at the same picture, but you're seeing different things. So that difference there is a difference in quality. Um, so Churchland wants to argue that we can reduce qualia to physical states if we adopt his new model of reduction. Um, now, it's not too confusing, but Churchland does sort of mix up. We sort of separate it out in this course. Um, Theory change right over time from synchronic reduction of like, chemistry to physics. Um, Churchland is sort of talking about both at the same time. Often he'll talk about um, an old theory reducing to a new theory, right? Um, and he sort of starts with Nagel's account and he says, okay, well, the TN, which is the new theory, plus the correspondence rule should logically entail deductively the old theory, right? So that's a Nagelian account of what it would be to reduce an old theory to a newer, better theory. But in this case, where it's theory change across time, he points out that it's actually very problematic because a lot of the time the old theory is false, which is why we wanted the new theory in the first place. If that's a deductive relation, then that means it's a bad argument, right? By modus tollens, we can refute the new theory. So um, at least in the case of diachronic theory change, we've seen lots of problems with, Footer pointed out some other problems with Nagel's account. Sort of a new problem with Nagel's account that arises when you're talking about theory change across time. Right? The old false theory seems to deductively refute the new theory that we think is true. So Churchill wants to propose an account of reduction that doesn't require this deductive relationship at all. Instead, what you want to do is still a deductive relationship in there, but what it is from the new theory, you deduce sort of a subset of that, like a smaller theory, and that theory is going to be an image of the old theory. And we'll cash out in more detail what it means to be an image. But you can sort of see, here we have an example of Frida Kahlo making an image of herself, right? And they're not exactly identical, clearly, the painting and the person, but there is symmetry there, right? There is sort of correspondence. Her nose is in the middle of her face. She has rather thick eyebrows, right, in both the person and the painting. Um, You might you might almost think of it as a structural similarity, right? Her face is arranged in a certain way, and the painting has her face arranged in the same way. So sort of the initial intuitive grasp on what it means to have an image of something, right? It's not identical, right? There's obviously differences, but in some ways they preserve the same structure. Okay. So Churchland's account of reduction is this. You have a new theory, right? Plus whatever various clauses, boundary conditions, limiting assumptions, whatever, right? Maybe if you were talking about reducing Newtonian mechanics to relativity, then you might say, okay, the new theory is relativity, but we'll take certain limiting assumptions, so the objects aren't moving very close to the speed of light, and they're not very massive, right, compared to the Earth and whatnot. Um, so that new theory with the conditions should then entail um, what he calls IN. So that'll be sort of a theory that's sort of a subset of the new theory, right? So for example, for all x, if ax, then bx, and those a and b might be anything, right? Um, for all x, if bx and cx, then dx. We've seen enough of these sorts of formulations. I don't have to try to fill in the details of what that might look like. But so we have some laws, and those aren't going to be identical to the old theory, but they will be an image of the old theory, although be relevantly isomorphic, right? So maybe the older theory TO has some laws that say for all x, jx, then kx. So right, structurally it looks very similar to the first one, ax and bx, but you just got j's where the a's are, k's where the b's are. And same with the next one. For all x, if kx and lx, then mx. Well, that's very similar to the thing we've deduced from the new theory. It's just that we got k's where the b's are, and so on, right? So that's what he means when he says isomorphic. So we have right, an image of the old theory that's been deduced from the new theory, and there's a similarity in structure. Um, but you're not going to have correspondence rules like you would in Nagel's account. So you're not going to say uh, everything that's an A, in the old theory is going to be a J in the new theory. Right? You're not going to say everything that's a desire to drink water is going to be a certain kind of brain state. You don't have that same kind of law. But what you do have is like a list of ordered pairs that facilitate this mapping. Right? Okay, well, when I say AX in the new theory, um, right, that sort of maps onto the J's in the old theory. It's not saying they're identical, but it is saying they sort of fill the same slot in the structure of these laws. So since we don't have a deductive relationship, we don't have these bridge laws claim identities. It's fine if the old theory is false, even if its terms don't even take out anything in the world. If the old theory, right, said something about phlogiston, because you're not going to have this deductive relationship, you're not going to be able to falsify the new theory by modus tollens. Um, but the point we're making with this isomorphism is that we're trying to show that the new theory is just as powerful as the old theory, right? Without committing to the literal truth of the old theory. Um, so now, without correspondence rules, as I said, we're not making identity claims between the things we talk about in the old theory and the things we talk about in the new theory. Um, but we have something close. We can make an identity claim in certain circumstances. And Churchland says we can do that when the reduction is, quote, smooth, right? So what does smoothness mean? Basically means a really good sort of tight fit between the image of the old theory and the old theory itself, where you don't have to do a bunch of like extra work to make it fit, right? Adding new laws and stuff like that, right? If you can just sort of smoothly deduce from the new theory something that looks exactly like the old theory, and the paradigm example being if I just state that okay, if I take relativity and say, look, I just want to talk about things that aren't moving very fast and aren't very big, you're going to get a very close fit to Newtonian mechanics, right? And maybe you're dealing with a different notion of mass than you are in Newtonian mechanics, but they're going to be very close images. Right? And here's sort of the picture of like we have a photorealistic image here of the actor from The Hangover, whose name is I think we all know who he is. Okay, so Uh, so that's a very sort of smooth, very exact image, kind of a smooth reduction, right? But what a smooth reduction does is it convinces itself that the causal powers of the property as described in the old theory are going to be the same as those posited in the new theory. And there are a lot of echoes of structural realism here, right? We're seeing that sort of filling the same role. Um, right? The equations are very similar, right? If you just substitute out sort of the properties, the predicates. That's the idea. Smooth reduction tells us we've latched on to sort of the same the thing that's doing the causal thing, even if it's a different name and maybe it's a slightly different sort of thing. We've latched onto this structure. So before we move on to the specific example of qualia and whether that can be reduced to neural properties, um, you got to note that a difference between everyday folk concepts, which sometimes can be reduced to the concepts in our theories, our best theories, but not always, right? And if they can't, that's not necessarily a failure of the theory. So I have a picture here of jadeite and nephrite. So once upon a time, um, we thought that there was only one, these were the same thing. We thought they were both jade. As it turns out, as our science got better, there's actually two very different substances that we call jade. So in that case, the science is getting it right, right? It's classifying things on the molecular structure and so on, not just on their appearance. Um, and on that basis, oh, these are actually two different things, right? So there are cases where we need to modify our folk concepts if the scientific concepts are better, right? Um, our folk concepts are a good start on sort of a systematic theory of the world, but they're just kind of haphazard. They're not right, as systematic as science. So we don't want to burden science with sort of like being able to reduce every single folk concept that ever sort of popped into a person's head, right? But sometimes folk concepts can be reduced to scientific concepts, right? So qualia, Churchland argues, is one of these, right? So we've got the sound of middle A, right? You hit A on a piano, sound experience, qualitative experience, qualia. It's also the case that that sound just is an oscillation of air pressure at 440 hertz, at least according to Churchland here. Red is a sort of qualitative experience, but it also happens to be a property of objects that reflects wavelengths of light. Right? So for Churchland, he thinks that these reductions can go through straight these folk concepts, right? We talked about a middle A note before we knew too much about neuroscience or the atmospheric science or any of that stuff. He says sometimes, yeah, we can just take a folk concept and map it right onto a scientific concept, and it's reduced, right? Again, according to his view, right, which is like we can do an image, right, of the two that really uh, is a close fit. Other things maybe not, right? In that if we have sort of folk concepts, we might have folk psychological concepts that we just need to get rid of, right? So there um, may not be a folk concept of anxiety as opposed to fear or something like that. That's just something I pulled out of a hat, right? But maybe there's folk psychological concepts that are very useful and they're better described scientifically. That can happen too. Um, and Trishman goes further to say we could even alter our vocabulary to match the scientific theory, and that's probably actually a good idea, right? Because scientific theory is more systematic. Um, it fits together in a nice framework. It makes better, clearer distinctions between things. So we kind of do this now, right? So I have this picture of one rush energy drink, but adrenaline, that's a new sort of concept that entered uh, our folk psychology. Now we talk about, oh, I feel if I'm feeling an adrenaline rush, right? And you have sort of a more exact way of describing your feeling, right? The feeling of excitement or whatever. It's a very particular thing that's occasioned by a chemical being introduced in your brain, and maybe that's the better way to describe that feeling you're having. Maybe that's an improvement of our vocabulary to introduce the term adrenaline. And even in everyday life, right? So, you get some training and you're able to pick out things in music that you couldn't before. Right? You can hear, oh, that's an oboe, right? Before maybe you wouldn't have noticed, right? You can hear, oh, they just changed the key, right? To C um, and so on, right? So we definitely have experience in our folk concepts of like as our theory of, for example, music gets more and more advanced, we're able to pick finer and finer distinctions. So it should make sense, a better conceptual repertoire allows you to understand and manipulate the world, even at the sort of folk theoretical level. So it certainly can't hurt to make use of right, our scientific vocabulary to further enrich right, our understanding of the world. And he says, just like it's going to be true of our inner conscious states. So, we have our folk psychological repertoire and it allows us to discriminate pains and smells. But just imagine if you had a better understanding of the neural underpinnings of that, you could really sort of use that to pick out in a finer way the feelings, the qualitative feelings that you were having. And so the example is adrenaline. Right? You have a name for this very specific sort of feeling you have, and it's maybe different than normal excitement. Right? So just imagine, right, if it can't hurt. It can only, Church will say, it can only improve our grasp on our own psychology to make use of the language and the theory of neuroscience. Uh, so he wants to say, yeah, it's not complete, right, but it's entirely possible that we could reduce qualia to neural states, right? And all you need is a theory that has adequate resources to describe all of your phenomena is described sort of introspectively in neural terms, right? So you have an image of your inner conscious world in the language of neuroscience, and it's going to capture all these causal relations. Right? When I feel pain, I want to pull away, right? Um, you have in the language of neuroscience what's going on in that situation, and maybe even a more fine-grained description. And it might turn out that some of our folk concepts aren't worth preserving in neuroscience, right? And so that's called eliminativism, right? Where you say, oh, actually, now that I have a better grasp of neuroscience, this word I was using, happy, uh, I don't need this word happy anymore. I have 10 other words that describe much more fine-grained states, right? And they don't exactly map on just on happiness because sometimes they're mixed with anxiety and sometimes they're mixed with longing or whatever, right? Um, so that may be the case that some of our folk concepts from introspection, once we understand better the neuro underpinnings and are able to sort of like uh, better describe our states on that basis, then maybe we would get rid of the term happy. That's entirely possible as well. All right, well, that is it. The last slide of the last lecture of this course. Thanks so much for coming along with me on this ride. I do hope you enjoyed it. I look forward to reading your final papers. On the whole, your drafts were really good. And so, yeah, that's it.